All right, let's get started. So we are working on this conversion, and when you deal with conversions, you want to break all values down to the lowest form, okay? Break them all the way down. You want to equalize them as much as possible. And so people look at these values and their eyeballs tend to dart toward something that looks like this because there are all these extra characters here. And so some of us have these brains that allow us to be tricked by this. We think, oh, more is better. But is it? Let's see. Okay, so we want to break these all into, or convert these into decimals to see which is least, which is greatest, and how to rank everything in between. So we already have a decimal here, okay? This is taken care of already. We only do anything except cross it off the list. Now, let's deal with 3/19. A rule of thumb, when you see fractions, know that these are also division problems, okay? Fractions are division problems too. And so that's another talk another time. You can divide 3 by 19. Divide the numerator by the denominator. Numerator by the denominator. The denominator goes on the outside. Or as I teach some people, divide the top by the bottom. The by goes on the outside, or the bottom goes on the outside. And so since you can't work 19 into 3, we add a decimal and then add a 0. Okay, and so now we get what appears to be 30. We have a modified 30 here, right? And 19 goes into that. So it goes in there once, boom, 19 times 1 is 19. Now we want to subtract. We get 11, or as my mom would say, 11. Bring down this 0. 19 goes into 110, about, looks like 5 times. Let's check to make sure. 5, 4, 9, 95, 10. Yeah, okay. So 5 times 19 is 95. Go on and subtract. And some of you might be wondering why I'm doing this by hand. Not all tests provide for the use of calculators. Some testers, like CBEST math testers, have to do everything by hand. So that's why I'm doing it this way. You may as well try to set some semblance of a decent example. Okay. Subtraction. All right, 10. 15. There we go. We need to drop another 0. So 19 into 150. Let's see, how many times would 20 go into 150? That would be 7 times. 19 is right under there. I think it's 7. Let's see. 7, 6, boom, 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 43. Yeah, 7. Minus 43. And really we can stop there because I advise folks to go 3 digits out. It's not likely that you'll be asked ever, well, it's not likely that you'll be asked to estimate anything beyond the thousandths place. And in case you are, keep going. But for these purposes, only go 3 digits out from the decimal point. So 3/19, and then make a note up here above this value, 3/19. So in decimal form, 3/19 is equal to 0.157, which is almost 16%. All right. Then we have 26% here. I think of percents the way I think of money. I think of decimals the way I think of money. So 26% I think of as 26 cents. And 26 cents without a currency sign would be 0.26. That's another talk for another time. All right, so we've got that one done. We've taken care of that one. All we have left is this sucker over here, 6 2/3%. And so, I know what you're thinking. Oh, well, this was 26% and it's 0.26. So this is also going to be 0.6. Close, but not quite. So if I were to think of this as money, again as currency, US currency to be exact, I would think of 6 cents. Okay, and if I were thinking of 6 cents, I know that a 0 goes here in the tenths place and that this 6 would go in the ones place, right? I'd have 6 pennies. I'd have 6 parts of 100, all right? 6%. But then I have this 2/3 over here. What am I gonna do with that? Now you can divide. You can divide 2 divided by 3, and you're gonna end up getting 0.6 in perpetuity. So let me save you the suspense, okay? All right. And so you just take these numbers and throw them behind this 6 here. So you're gonna have 0.0666, and we go into depth on how to work with this when we're actually in session. Okay, so here 6 2/3% is actually 0.0666 in perpetuity. You almost have 7 pennies. Not quite 7, almost 7 pennies. Okay, and so if we want to continue, we can insert our results in a place value chart. Something I highly recommend. Don't try to eyeball placements, okay? It'll trip you up every time, especially when you're testing, and especially if you're not really good with numbers. I recommend that you avoid going into a test situation fatigued, but if you do, or if this is one of the last problems on which you work and your eyeballs and brain fail you, then they might trick you. Okay, so go on and draw a place value chart. I'm all about visuals. Boom, boom. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And we are focused on everything, it looks like, on the right side of the decimal point. So we don't need to worry about whole numbers at all. We're dealing with parts. So we have, let me see, point, first off, do we have any, you know what, never mind, let me not do that. 157, let's just go across. 0.26, 0.083, and 0.0666, just because. Okay, so don't be fooled by the presence of these extra digits. Because if we cared about these, then this could be a contender. We only have 0.157 here because I stopped. Okay, that's it. There would have been other digits here. Okay, and the presence of these digits means that this value is just being broken up into smaller and smaller pieces. That's all that means. It doesn't mean that these are worth more than these digits here. The larger a digit is here, the closer it is to the decimal point on the left hand side, the more meaning that has in terms of rank for the other numbers. So for example, we have 0021. Okay, 2 is the highest number in this column. So this is your greatest value. Okay, this is your greatest value. Okay, now let's look at the others. We have 0.08 and we have 0.06. And if you are guessing that 0.06 is going to be the lowest, you guessed right, okay? And so, let me erase these quick. Okay, so if we're ranking these from lowest to highest, this would be 1 because it's the lowest. We have another 0.0 here, 0.08. This is going to be the second. We said this is the highest because we have 0.2 here. So, oops, my bad. 4. And now we have this 0.157. So this is number 3. So if you were to answer this question, if you were required to list these in order, make sure that you are looking at the original versions of these, okay? So 0.157 is assigned to 3/19, 0.26 is assigned to 26%, 0.083 is assigned to 0.083, and 0.06666666 is assigned to 6 2/3%. So if you see, not if you see, sorry, your answer should look like this. 6 2/3%. Okay, and then you want number 2, 0.083. Okay, and then you want 0.157, whose equivalent is 3/19. And lastly, you want 0.26. All right, this is what you want right there. So there you have it. You have broken all values down to the lowest form. You have inserted the results in a value chart, and then you ranked the values, and that takes care of that. Give it a try.